follow the driverless car craze, then most have heard the horrific incident when a Tesla autopilot vehicle mistakenly took the back of a semi-truck as a billboard, and this resulted in the death of a driver. Driverless car popularity has become the new technological race for large technology companies. So this semester, my team in the Georgia Tech Sonification Lab, under the direction of Dr. Bruce Walker, focused on how to maintain driver vigilance, inform the driver when the vehicle's reliability becomes uncertain, and alert the driver when a point of interest needs feedback or driver intervention. We created a demo using a driving simulator and an eye tracker to track the driver's gaze and alert the driver to maintain vigilance. This is achieved both visually and audibly by locating the point of interest and using sonification and heads-up display to inform the driver of an uncertain point of interest, so that the driver can decide if he or she needs to take back control of the car. Our main goal is to create a safer, more reliable driving experience when handing off the task of driving to a machine. First, we'll look at the visual prototype. In order to locate the point of interest as quickly as possible, a visual indication would be displayed on the windshield identifying the uncertainty of the vehicle. Here you can see the multiple visual indicators created for testing purposes to not only relay positional information, but autonomy uncertainty as well. Next is the audio prototype. The audio heads-up display was created using an audio programming language called Maxim SP. The approach was to simulate a windshield of a vehicle utilizing the blue rectangle and a point of interest utilizing the red dot. The idea is to alert drivers where the point of interest occurs on the windshield of the vehicle when the driver may not be paying attention during automation. The x-axis is mapped to the left and right stereo outputs to represent the left, center, and right areas of the windshield. The z-axis represents the distance of the point of interest, which adds reverberation when the object is far away, giving a spatial feeling to the audio. The z-axis also contains an urgency component, which pulses quicker the closer the point of interest becomes. The y-axis was a little harder to find an intuitive way to represent, so 3 ideas were prototyped. The first and second prototypes use pitch and frequency modulation to represent the top and bottom of the windshield. The higher the pitch or modulation, the higher the point of interest is on the windshield, and vice versa. The third prototype used a filtering technique to represent the top and bottom of the windshield. The approach is to filter the audio in the car with either a low or high pass filter to dynamically change the output audio in the car. The high pass audio would represent points of interest higher on the windshield, and the low pass filter would do the opposite. This was a novel approach that could be minimally invasive to the driver, but with little cognitive training, learn what the sounds mean and quickly be able to recognize the points of interest without the annoyance of an alarm. So let's check out a versatile demo, the pitch prototype. Second, I will demo the frequency modulation prototype. And finally, third is the audio filtering technique. The only difference for this one is that you have to load the audio file to play. This simulates like you're playing an audio track from Spotify in your car. And you do this by using the read button here. Once you've loaded in the track, then you have to start the audio playback by pressing the play button on the play bar here. And then you can listen back and move the point of interest around the windshield again to hear the different filters, or set the manual positions yourself. Now here is a video demo of how both systems would work in a simulated environment and could eventually be developed for real-world applications. For watching, and if you are interested in any more information about this project or others, please contact us.